Hey everybody, welcome back. It is another round of geometry. Today we're going to be talking about the area of parallelograms and the area of trapezoids. It's going to be very similar, at least parallelograms, very similar to rectangles and quadrilaterals. Okay, so today we are going to find the area of parallelograms and trapezoids. Don't forget about those wonderful trapezoids. Okay, so we will be talking about both parallelograms and trapezoids. Again, like I said, it's going to be very similar to quadrilaterals. Okay, forgot my words there for a second. So the area of a parallelogram. Pause now. Please write this down. Make sure you draw the shape to give you a better understanding of what it is. Alright, so you're going to be writing down the area of a parallelogram. It is the base times the height. Again, your base is going to be that bottom segment, okay, and your height is going to be where you take from a vertice and all the way down to a base, and it's going to form that wonderful perpendicular angle, which is 90 degrees. Alright, so it's going to form a perpendicular angle. Okay, this idea, find the missing measure, sorry about that. So plug these, again, using that same formula of area equals base times height. Okay, solve for that missing variable. Give it a shot, pause now, try to answer. Alright, so now notice that we know our area down here. Okay, and we also know our base, which is going to be right there. Plugging this into our equation of area equals base times height, you're going to come up with 72 is equal to, we know our base is 12, okay, as you can see, that's that bottom line there, the bottom line segment, times our height. Okay, now remember from our one-step equations, we have to undo the operation of what's happening. We see that it is multiplying, so we need to divide. So we're going to divide by 12 on each side, and 72 divided by 12, and our height, not our area, our height is going to be what? You got it. We're going to have 6. Now, notice here we have an area of inches squared. Don't get caught up in that label because remember, we have to take inches times inches. So our height is going to be a singular unit of inches. All right. Same idea on this right problem. You're going to notice we do know our area of 96. This time we have our height. But again, we use that same formula that we've been using in the past of area equals base times height. Plug it in and solve for B. Alright, so area is 96. We're going to equal, we don't know what our base is, but we do know our height of 8 centimeters. These two multiplying, here we're multiplying 8 times B, which means we have to undo the operation, which means we are dividing by 8. So B is going to equal 96 divided by 8, 12. And don't forget our label. What is our label? Centimeters. Centimeters this time. Again, our area is going to have a unit of the unit squared. When we have our base and our height, they're just going to be singular units. Alright, nice job. Moving on. Alright, area of a rhombus. This is a little bit different because now, remember, what classifies this as a rhombus? Yep, you got it. Absolutely, all our segments or all our sides are going to be congruent. So this time, notice we're going to have the area is equal to half times the product of the diagonals. So initially what you're going to do is you're going to take half times D1 times D2, or multiplying half times your diagonal. The other way you could do it is multiply your two diagonals by each other and then divide by 2. If you have those, you can divide by 2 and get your answer. So please pause now, write this down. Notice that wonderful bright yellow bar at the top and finish up. Alright, moving on. It says finding the area of the rhombus. Again, we know that the area of a rhombus, our area is equal to half times D1 times D2. If you look at this one on the left, okay, this is going to be, don't let this fool you, because this right here, our segment, sorry, I'll use a different color so you can see, this segment right here is only half of our full diagonal. So we need to find what this full diagonal is. So what do we have to do? Yep, we have to add those two together to get our full diagonal. Same thing on this horizontal one. We have 5 and 5. We have to add those together to get our D2. So I want you to give that one a shot. Pause now and try it out. Alright, so now that you've tried that out, let's see if it is correct. Again, area is equal to half times the diagonal 1 times diagonal 2. So if you multiply these out, you're going to have A is equal to half. And again, you're going to have 3 plus 3, because that's your full diagonal, and 5 plus 5. When you multiply these out, you're going to get half times 6 times 10. Again, using more than one step. It's alright if you use more than one step. You're showing your work. That'd be great. Okay, multiplying half times 60, because we know that 6 times 10 is equal to 60. Taking half of that, we're going to have our answer of area is equal to 30. 60 divided by 2 is going to be 30. Notice on this one, we do not have a unit. Why? Because in this problem, there's no units. So if there's no units in the problem, there's going to be no units in the answer. All right? Taking this next rhombus, if you notice, the horizontal one up on top is going to be 7. That gives you your entire diagonal. Not bits and pieces like that first problem, but your entire diagonal going across horizontally is 7. Going vertically, again, that is your entire diagonal. All right, the vertical one is 12, knowing that your equation is half times D1 times D2. Try to plug those in and solve. Pause now, give it a shot. All right, now multiplying these out, again, we're going to take your area is equal to half times 7 times 12. When you multiply 7 times 12 together, you're going to come up with, what is it going to be? You got it, 84. Then you take half times 84, and your area is going to come out to be 42. Again, is there units in the problem? No, there is no units in the problem, so there is no units in your answer. All right, moving on, just a couple more slides, ladies and gents, and we are finished. All right, area of a trapezoid. All right, this is the next piece. We're going to have a couple examples here, and then we will be done. All right, pause now. Try to write this down. All right, area of a trapezoid. In words, okay, it's going to be area is equal to half times the height times the sum of the bases. So notice under your symbols, you're going to have B1 plus B2 multiplying by your height, multiplying by half. All right, so there's a couple different steps that were a little different than normal, but again, your height is going to be that vertical line that is going to be, I suppose it can be also horizontal, but it's going to go from one base to the other base, and it's going to connect at a perpendicular angle, or a 90-degree angle. We're going to try a couple of problems here. Here we go. It says find the area or the missing measure. Ooh, lucked out. We're not going to have any missing measures one here. All we're going to do is figure out what the area is. So again, writing down, very first thing, start with what is the area? How do we find the area of a trapezoid? So try that out. What is it again? Yep, area is equal to half times the height times the sum of B1 plus B2. Alright, so looking at this one on the left, we have our B1 of 6 inches, our B2 of 8 inches. And notice, it really doesn't matter which one is your B1, which one is your B2. Normally, your base 1 is going to be the smaller unit, your base 2 is going to be the larger unit, but because we are adding them together, it really doesn't matter which one you use for your base 1 and your base 2. As long as you have a base 1, you'll automatically have a base 2 with trapezoids. Okay, so try this one out. If you finish this one, give the next one a shot if you want. Alright, so base 1 of 6 inches, our base 2 is 8 inches. Our height is going to be equal to 5 inches. Plugging this into our equation, our area is equal to half times our height of 5 inches times the sum of 6 plus 8. Adding those together, you come up with your next step of half times 14. Or sorry, times 5 times 14. I'm getting a little ahead of myself. Alright, so now we have 5 times 14. When you multiply these together, you get half times 70. That's what 5 times 14 is. Take half of 70, so what is your area going to be? Area is equal to 35. Ooh, I almost said 70 there. I was looking at the 70. Your area is equal to 35. Now, what is our units? Alright, we have our base 1 units of inches, our height units of inches, our base 2 units of inches, our area, inches squared. Remember, area is always going to be units squared. Next piece, again, you have your base 1 here at the top is going to be, your base 1 is 7 meters, your base 2 is 11 meters. What's your height? You got it. It's going to be 7. So, plugging those in, give that one a shot, unless you've already tried it. Give that one a shot and solve. Alright, plugging these into our equation, area is equal to half times our height of 7 times, when we add these two together, remember we're going to take 7 plus 11. And class, what is 7 plus 11? You got it. It is always, always, always 18. Positive 7 plus a positive 11. That is an ugly 8. Holy buckets, where did I learn how to write? Bunch of chicken scratch there. Okay. So now, plugging in half times 7 times 18. Now, if you want to, you can take half of 18 first and then multiply by 7. It doesn't matter. Order of operations normally is from left to right, but you can mix and match things. If you know what half of one and then multiplying it by the other, that's fine. All right, you figure out what's the best for you. All right, so now you have 7 times 18. I'm going to do it that way. 7 times 18 is going to be what? You got it, half times 126. So now that we got 126, we need to take half of what 126 is. When you take half of what 126 is, you are going to get an area of 63. What's your units? Meters squared. Okay, meters squared. Again, units squared for area, singular units for height and base. And base 1, base 2, diagonal 1, diagonal 2. Those are all singular units. We are done for tonight. Nice work, everybody. See you tomorrow.